Hola! We are going to talk about our two final derivative families today, the grandmas of the group, esters and ethers. Now, make sure you pronounce it right so you don't sound silly. Ester, ether. So let's look at these. Let's start with our good friend, ether. So ethers, I feel like that's a word that you've probably heard before. So ethers are really simple. They're probably the easiest of them all. They look like this. You've got two R groups that can be the same or different, and they are connected by a very simple oxygen right in the middle. To name them, the name is going to end in ether. So watch, this is like really crazy. So let's say we've got CH3, O, CH2, CH3. Now, this is wild. So look right here. On this side, this R group is a methyl, right? And then the R group on the other side has two carbons, so this is an ethyl, right? Do you see how this is an oxygen in the middle? This is what's telling me I've got an ether. So we are going to go in ABC order as per usual, and we are going to name this thing, wait for it, ethyl, methyl, ether. Like, really brilliant, huh? Okay, so ethers are really simple. You can tell that it's an ether because it's got two R groups that are connected by an oxygen in the middle. Okay, ester. Let's discuss esters. So esters look shockingly like ethers, but with one difference. An ester also has two R groups. However, and there is an oxygen, but at the end of one of the R groups, you've got a double bonded oxygen. So what that means is you actually have two oxygens. One's double bonded and the other is single bonded. So this part's going to get not too complicated, but I'll show you how it works. Esters are going to end in O8. All right, they're going to end in O8. So you're going to drop the E and put O8 on it. So let me show you what this looks like. Okay, so let me give you this as an example. I'm just going to draw carbons so I don't get us too confused. Oops, well, wouldn't it be nice if I could draw this the right way? All right. All right, so here's an example. So there's kind of two pieces here. Like, do you see that I'm going to sort of divide this thing in half at the oxygen? I'm going to draw like a little halfway mark. So this side has two carbons, right? So this is an ethyl. And this side has four carbons. So this is a butyl. The side with the double bonded oxygen is going to be our parent side. All right, that's going to be the main chain. So the butyl is going to get the O8. So this is going to be butanoate. And the ethyl is going to be the branch. So ethyl butanoate. All right, and let me say that again. I split this in half at the oxygen, and I counted carbons on both sides. So butyl, ethyl. The side that has the carbonyl, the double bonded oxygen, is going to be the O8 side. All right, so this side is a branch. Ethyl butanoate. Let me do that again, and I'm going to show you a different example, and I'm going to turn this thing around. Okay, here's another one. Again, I'm going to kind of divide in half at my O. I'm going to look over here, and I've got 1, 2, 3. So this is going to be a prop. And then on the other side, I've got 1, 2, 3, 4, 5. So this is going to be a pent. This side has the carbonyl, the double bonded oxygen. So that side's going to get the O8. So pentanoate. And then my propyl becomes the branch, so propyl pentanoate. All right? I hope that makes sense. Now that we've got these all down, so we've talked about all of our families. We've got aldehydes and ketones and carboxylic acids and alcohols and ethers and ethers and esters and blah, all of them. So now the key is going to be deciding which one you're dealing with. So let's talk about a couple examples real quick. Like, let's say I ask you to draw pentanol. Where are you going to start with this? The first thing you're going to do is you are going to go straight to the end and find out what that end is. So this is OL. Which of our families tell us about OL? That's going to be our alcohols, right? That's going to be our alcohols. So you're going to go find, what does alcohol mean? Well, alcohol means that there's a hydroxyl group. So we can now look at this and say, all right, we've got pent, so 1, 2, 3, 4, 5, with an alcohol on it. There's no number at the beginning, so the OH has to go at the end. So I could look at this and say CH2, 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 CH3. This must be pentanol. What about if I give you, let's see, 5-chloro, 2-hexanone. Okay, what did we just say? You're going to go straight to the end. One. What does hexanone look like? Well, it's a ketone, and ketones have a double bonded oxygen on them. And guess where that's going to be? Boom, right here on carbon 2. I know it's hex, so I'm going to go draw my 6. 4, 5, 6. On carbon 2, I'm going to put the carbonyl. And on carbon 5, I'm going to put a chloro. After that, I'm just going to fill it in just like normal. Make sure you know how to count to 4. Right? And we're done. So when you go to draw these, always start at the end. The end, as per usual, will tell you what you need. Then go look at the prefix. It's going to tell you how many carbons on your parent chain. And then fill in your branches as usual. Okay, I hope that helps. Yeah, okay, you got this. You guys are the best.